Hey guys, so welcome to the second video in the software engineering lesson series. So in this video, we're going to continue the trend of me basically telling you guys a bunch of lessons, a bunch of epiphanies that I've had throughout my many years as a software engineer. So let's just go ahead and get right down to the first lesson. So there is a misconception in the general community about software engineers. A lot of people falsely tend to think that software engineering is all about writing tons and tons of new code. That couldn't be further from the truth. So basically, as a software engineer, the vast majority of your time, the vast majority of your time, you're actually going to be spending working on an existing code base. So you're going to be debugging, so fixing, and extending an already existing code base. Now, what this means is that you need to get really good at investigating, analyzing, and understanding the relevant parts of a code base. So, most likely you're going to be working on a code base that's huge. And you don't want to have to learn the whole entire thing. And in a lot of the cases you can't, because this code base might have been written, by hundreds or perhaps thousands of people. So how could you possibly, learn all of this? You can't. So really what you need to get good at is learning just the relevant parts of an existing code base, so that you can fix a certain bug or so that you can extend it in some way. So I'm going to tell you about a simple strategy that you can use, to quickly gain knowledge about the relevant part of a code base in order to fix a bug. But it's important to know that the specific strategies here don't matter. What matters is that you keep this fact in mind, and it is a fact. The vast majority of the time you're going to spend as a software engineer is working on an existing code base. And so in the back of your mind, keep that there, so that, as you continue to work with these big code bases, you learn to develop your own strategies based on your own personal background on how you want to, handle this, how you want to learn it best. But I will give you a simple strategy. So oftentimes, when I have a bug, in an existing code base that I'm working on, I start out by creating the smallest application, the smallest example that demonstrates the bug. So the smallest thing that just shows you the bug in action. Create that small test application, launch it, and actually look at the bug, watch the bug. So basically you want to see that the bug actually exists. That's important. So step one, once you see the bug, now go ahead and place a few breakpoints in the relevant parts of the code. Execute the relevant parts of the program while you have a debugger attached to it. And then, step through your breakpoints. Look at the local variables, and this process of debugging through your really small, isolated example application will actually tell you quite a bit about the relevant parts of the code and how they work. You can also, if just reading the code and stepping through it isn't helping, you could mess with it, change a few variables. A lot of debuggers, they let you on the fly change some variables depending on the language. Do that and see the results. So that's just one, and then also when you have an idea on how to fix it and you go ahead and make your code changes, now you have a test program. So you can quickly see if, what you changed actually fixed the original bug. So this is a good little strategy, but as I mentioned earlier, the specific strategies on how you can understand an existing code base, that's not important. You will develop your own specific strategies that are, proper for your own background, because we all come from a different background. We have a different knowledge base. You'll develop your own strategies. The important thing is that as a software engineer, you want to keep this fact in the back of your mind, that you need to constantly look out for ways that you can increase your ability to learn existing code bases. Okay, so the second tip that I have for you in this video is that oftentimes the cause of your frustrating bugs is something simple and obvious. So you need to, go back to the time-consuming basics. Here's what I mean. Let me elaborate. So here's a common situation that a lot of the more experienced programmers will definitely relate to. You're working on some bug, and you've been working on this bug for hours, and there's something that's happening, and you're absolutely sure that there's no way that this can be happening. You're sure that what is happening There is absolutely no reason for it to be happening. You have a lot of assumptions. So what this really means is that, be real with yourself. Obviously, one of your assumptions is false. You're thinking that there's no way that this can be happening because of assumptions A, B, C, D, whatever, right? But clearly it is happening. So one of your assumptions is false. It is now time for you to go ahead and fire up your IDE, attach the debugger to the program, step through it line by line and step by step, look at all the local variables, look at all the relevant variables at each step and make sure, assert that your assumptions are indeed correct. You may be saying, hey, this is super obvious. Why are you telling us this? Well, the reason for this is because it's so freaking common. As you gain experience as a developer, you start to make leaps, right? Little jumps, especially as you gain experience with the same code base. You begin to know the code base and the process so well that you start making an assumption. You're like, yeah, that file is there. I know it's there. It's being opened. So why am I having this bug? And this is a problem that, beginners tend to not have because they don't have this experience, so they can't take these leaps. But as you gain experience, you tend to take these leaps. And, most of the times they save you time because your assumptions prevent you from looking at irrelevant parts of the code and you solve the bug faster. But sometimes they actually bite you. So what you need to do is if you've been stuck on the same bug for hours and it's simple, suck up your pride a little bit, and just go ahead, fire up your IDE and step through it line by line, step by step, looking at all the variables, just like you did when you started programming. There's no shame in it. Sometimes you have to fall back to the time-consuming basics that have been tried and true. Okay, so this next tip that I have for you, I really, really like this one. It's one of my favorite ones. So anytime you're ready to take a break, or if you're just ready to go home, the work is done, the work day is done, you want to spend a couple minutes, maybe 5 minutes, writing down your thoughts, So if you're working on something, if you're solving some bug, or if you're working on a new feature, you want to go ahead and write those down. So that you don't forget it, and so that you don't have to keep it in your head. So there's two advantages for this. One, the obvious one, is when you come back from your break or when you come back the next day, you can quickly pick back up, right? Because you have your thoughts written down. The second and more important advantage of this is that, when you're ready to go home, when you're ready to go on your break and you write down your thoughts, you free your mind, right? You don't have to keep these thoughts lingering in your mind during your break or when you're at home, spending time with your family or whatever. You don't have to keep these thoughts in the back of your mind. You've written them down. They're not going anywhere, so you can let them go and you can truly have a relaxing and rejuvenating break, which is really, really important. Software engineering is often it's a mentally taxing profession. You use a lot of mental energy and you want your breaks to be true breaks, not, these fake, not these fake breaks where you're kind of like keeping the information in the back of your head anyways, because you don't want to forget it, right? Well, if you write things down, you're not going to forget them. They're right there for when you come back. You can truly enjoy a relaxing and rejuvenating break. Okay, and the last tip that I have for you, I'm going to tell you the secret. This is starting to sound like some scam, but there's no secret. This is very well known, but I like to call it the secret to developing large software systems. So the key to developing large software systems is to develop your components such that they're small, cohesive, modular, and loosely coupled. So let's go ahead and break those parts down a little bit. Small basically means, it's obvious. You want to make your classes small. You want to make your function small. You want to make your file small. You want to make your folder small. You want to make, at every level, you want to make everything as small as possible. So how do you make a class small? Well, you give it less member functions. How do you make a file small? Well, you give it less stuff in the file. So, maybe less classes in the file, less, entities in the file in general. How do you make a folder small? Less files in the folder. This can be applied at a lot of levels. Make your components at every level as small as possible. Now, the other advantage of small is that small components, naturally, they tend to be cohesive. So let's go ahead and cover cohesiveness. Cohesive just basically means that related things are grouped together, right? So a cohesive class is a class such that all of its member functions are somewhat related. So, for example, if you have a class that does a bunch of, triangle calculations, right? Would it make sense for this class to, tell you the name of a certain US president given a year? It's completely irrelevant. Why would you give this class that's responsible for triangle calculations just a function that can tell you the name of a president given a year? That's irrelevant. So that would be an example of a very non-cohesive class. Similarly, you can make your folders cohesive by grouping related files, putting only related files in that folder. And even a specific file you can make cohesive by putting related entities in that file. Now, modular and loosely coupled are pretty related. So modular just means that oftentimes you have components that depend on one another. So you have one class A, that depends on class B. It uses class B internally for something, right? So modular means that when class A depends on class B, it doesn't strictly depend on class B itself, but rather it depends on the interface that class B exposes. So if class C comes along and it exposes the same interface as class B, then class A can use class C. And this is also what we call loosely coupled, because class A doesn't strictly depend on class B, it just depends on its interface. We say that there's loose coupling between those components, right? They don't directly depend on each other. Class A just depends on the interface that class B exposes. So you see that if you make your programs modular, you naturally get loosely coupled. If you make them small, you naturally get cohesive. So I'm going to give you a quick little tip, and then I'm going to end this video because it might be getting a bit long. So, these things, making cohesive components, making them loosely coupled, making them modular, these concepts, come from, software engineering principles, right? These are, the principles that guide you to create good software systems. And a good software system is one that can easily be extended, it can easily be modified, and it can easily be fixed. It's maintainable and extensible, right? So I don't know about you guys, but I'm going to tell you a little story as well. I think I have a couple minutes. When I started out, programming, I remember I would have, a very tiny program. It would just start out, maybe 50 lines of code. No problem. I could extend it to 100, 200. I could keep adding these new features. And as my lines of code grew in the hundreds, no problem. I could still continue to add things. But when I started hitting the thousands, right? When I start getting to 1,000, 2,000, 3,000 lines of code, now when I, add a new feature, I break a bunch of other stuff, right? So I had this problem, project after project that I would do. My projects would be fine up until they got to a couple of thousand lines of code. And then it would seem like it was so difficult to add new stuff to it. So this is the software scalability problem. This is a well-studied problem in software engineering. And there's a bunch of, tried and true software engineering principles that people have applied for decades and that lots of research has gone into, that can help you create systems so that you wouldn't have that problem, so that you can continue to add to this system. You can continue to extend it, right? And I just told you a couple of these software engineering principles: cohesiveness, modularity, and loose coupling. There's lots more. A lot of the times when you aim for one of the software engineering principles, the other ones naturally come for free. For example, if you try to make your components small, they naturally tend to become cohesive. That's not always true, because you can have small components that are not very cohesive at all. But usually, if you get one, you get the other for free. But there's also cases where sometimes these software engineering principles, they fight one another. So you can't have your cake and eat it too. You can't have all of them. You have to balance them a little bit and pick the ones that are most important for your project. And one last little tip I'm going to leave you, and then I'm really going to cut this video down, is there's a book called, I think it's Head First Design Patterns. I know that the Heads First series is polarizing. Some people seem to love it. Some people seem to really hate them. I like them. I've only read 2 of their books, and the Head First Design Patterns I really, really enjoyed. It was the best software engineering book that I've ever read. Basically, the book is on design patterns, as the name suggests, but design patterns are built on top of tried and true software engineering principles. And they explain these principles, and they do a really, really good job of explaining these principles in that book. So if you're interested more about how to build large software systems based on tried and true software engineering principles, I'd highly recommend the Head First Design Patterns book. Okay, so that's it. I'm going to cut this video. It's getting a little bit long. Those are another few tips that I've learned throughout my years of software engineering. I hope that you guys enjoyed this video. I hope that you're enjoying this series in general. I'm really enjoying actually making these videos because it reinforces the concepts in my head as well. And if you guys have any follow-up questions, post it in the comments. I'm really good at getting back. I'm really good at responding to comments very quickly. So if you have any questions, any clarifications, if you need help with anything, go ahead, post it in the comments, and I'll get back to you very quickly. So thank you so much for watching this video, and I hope to see you in another one of my videos. Bye bye.